All right, we are back online. I think I just got a B-sod, so it crashed. Let us get started. As I was saying, Monday is your AP test. You want to read up on all the emails that you're getting from College Board. Today we'll do a couple of things. Number one, we'll go over the quizzes, and then and also run you through a simulator of the College Board platform that you'll be using. So it is stated that 2 days before your test, so for you guys it's either today or tomorrow, that you'll get an email from College Board that gives you your credentials that you'll use to log in. Now you should know your College Board ID, your AP ID, and if you do, you would type this. So you'd go, so you'd click on the link that was sent by College Board. So today or tomorrow you'll get something, and then you'll go to a page. This page is a demo, so you can actually use this demo to practice. If you just go to AP 2020 examdemo.collegeboard.org, you can practice. But basically, the link will take you to a page like this where you enter your ID. And so for this demo, we can just use practice. Now I have to do this practice. I have to do this in conjunction or in parallel to the quiz review, because there's some timers that I can't skip. So while the timers are going, we'll go and do quiz review and stuff. If you don't know your ID, yikes. Well, what you could do is go to your My AP and look at any of your reports. Like if you took an SAT test or something, look at one of your SAT reports. You'll see your AP ID there. Or it's in the it's if you look at the if you get the email from College Board for Monday's test, you'll see it there as well. All right, so here's a practice. So this is where you would type in your ID, not the word practice, and then let's see, get started. Yeah, sure. All right, so you'd enter your name and all of this stuff. Let's see, name. What's my name? My name is Stephen Davis. Date of birth. Of course, everyone is born on January 1st. I don't know how many people in this world have the same birthday, but I'm gonna guess about 6 billion. Stephen, how old are you? Well, I'm 16 years old, taking AP Physics C. So here we go. All right, and then of course your email address, school ID. I am 010101@ecrchs.org, and let's go and confirm my email at ecrchs.org. It's gonna say .net, but teachers have .net. I'm a youngin' taking APC. I have everything to look forward to. What are you testing? Where are you testing from? I'm testing from home. All right, done. Permission to whatever. So basically, they're gonna track you. They're basically gonna pull some NSA stuff on you. You track your packets that you're getting. So don't do anything stupid. Don't try to cheat. Only have this window open. So as you can see, I only have this window open. I'm also using the new Chromium version of the Edge browser. Did you know the Edge browser is actually a lot better now? And the Chromium version of Edge is even faster than Google Chrome. No, it's not regular Edge. It is Chromium Edge. Because Google Chrome actually uses way too much RAM. I don't know what it's doing in the background, but it's using way too much RAM for my own taste. So anyway, let's go and agree, because what else are we gonna do? Not agree? All right, so again, there's this timer. Your test will begin soon, blah blah blah. It shows you different ways. These are stuff that you should read ahead of time. It's in the email. So boom, as soon as the timer ends, your question begins. So basically you'll have this gray box and your question will be inside this gray box. Now, I would recommend having Microsoft Word open. So you are allowed to have Microsoft Word open at the same time you have this browser open with this singular tab. So on the side, you have your Microsoft Word, and on your Microsoft Word, you can start typing and trying to answer the question. So in this box, you'll see this question. You have your timer there, and then you can always answer any time you want within the question time. Remember, you get 2 timers. So for you, it would be 25 minutes. Even though this one says like 10, it would be 25 minutes, and then you have 25 minutes to read and do whatever, type your answer on Microsoft Word, okay? And then followed by an additional 5 minutes to where you can paste your answer. Technically, you know, you could use that extra bit of time to finalize your thoughts, but remember, when that 25 minutes is up, you won't be able to see the question. So hopefully you know everything you need to. If you want to maximize your time by using that 5 minutes for the copy pasta time as calculation time. So anyway, so you have your question. So what's question? Okay. Construct a device to open up a wormhole to travel to Alpha Centauri. All right, well, good luck. Here we go. Let's see, what do I need to do? Consider all the lab devices that you need, what kind of measurements you want to take, formulate some sort of equation, explain the equation, justify your answer. Okay. So here's my answer. All right, and then once you're ready, you can just hit paste response. Now in the paste response, you cannot type. You can't actually type in here. Okay, what you could do is Control V. So go to your Microsoft Word, Control A, Control C, and then come back to this thing here, and then hit Control V. And Control V will paste whatever you have. Oh, here's my answer. Rengar is OP. Please nerf. And then go ahead and submit. Boom. You will not be able to return to the question once you complete the step. That's fine. All right, moving on. Okay, and then you're supposed to get some, the 5 minutes. No, not documents. You Control A to select all. Control C to copy. Go to browser. Control V to paste. So you are pasting text. And if you read your email, there are other ways to submit. So pasting from Microsoft Word is not the only way. You can attach a file like images. So if you can use your phone to take an image, send the image to yourself, and then upload the image. And so that's also an option. So photo guidelines. Let's see, photo guidelines. So let's say you do it on paper, and then you take pictures. Requirements. And when you are submitting, at the top, you're supposed to write your initials and your ID. Write your AP ID, your initials, and the page number of the top of each page. You can only attach one photo at a time. Do not hit submit until you've attached all photos. Ooh, this one's important. Right? If you're doing photos, you want to upload one at a time. Submit doesn't mean upload the picture. Submit means turn in whatever you have. Honestly, that's way too much work. I would just try to do everything on Microsoft Word and copy paste it. Yeah, so so you don't want to prematurely submit when you just uploaded one. Technically, they can do PNG, JPEG, JPG, minimum file size 10, maximum file size 25. Now, some of you, might have like 1,000 megapixel camera, so your file size is maybe way too big. You might have to change the setting. Isn't the new Samsung phone like 100 megapixels? Yeah, I think the new Samsung is like literally 100 megapixels. Recommendations, or whatever. All right, so that's our platform. Play around with this. See which one you prefer. If you like copy pasta or if you like actually uploading. Again, I would say uploading is a little risky, just because you might hit submit accidentally and then there goes your grade. 8K photo. Yeah. All right. Anyway, go to ap2020examdemo.collegeboard.org, and that should allow you to practice the platform. All right. Now, this is the demo is obviously different. They're giving you different amounts of time. Your timing is 25 minutes for question 1, 5 minutes to paste, followed by 15 minutes for question 2, 5 minutes to paste, and then you're done. All right, let's get to these quizzes. We got work to do. Now, I hope that by doing your College Board FRQ assignment, which is due tomorrow, hopefully everyone turns it in today, not tomorrow, which is due tomorrow, you'll get better and better. But we definitely need to step on the gas. This is it. You've worked so hard, literally for 2 years. If there's any weekend where you just don't watch Netflix, it's this weekend. Just do some physics. Monday morning, 9 o'clock, get it done, and then you're pretty much done with physics. Tomorrow, meaning today at midnight. Yeah, I think the best thing to do is just lie to students about due dates, because that's the only way they will submit things. College Board F. No. You deserve a Z Fizzy L. All right. Let's take a look at the quizzes. Man, the quizzes. Holy moly! Starting with Tuesday's quiz. Should we do multiple choice? I guess we can. Multiple choice. Let's run it through real quick. APCR quiz number 2. Speed, grade, no, quiz statistics. All right, starting with the first MC. All right, a uniform solid cylindrical log begins to roll a log down a ramp. That's how easy this question was. Log down a ramp. The ramp is 28 degrees. You find the acceleration. So here's my log. So here's my ramp. 28 degrees. The log is a cylinder. A cylinder is the same as a disc, and the disc is 1/2 mr squared. Yeah, so it tells you note, answer with this many sig figs, right? So yeah, so you need to isolate. If you follow the 7 steps in doing well in physics, then there's no way you'll get it wrong, because this is why you isolate first instead of plugging stuff in, such that you get your final answer and then you round your final answer to the proper sig figs. All right, Sword Hero says Kekarot and KE. Yep. So we started with Peg McGuh up top. At the bottom, well, it's not technically bottom. What it does say is that we're rolling down a certain amount of distance. I'll just call it D. I'll call this theta. I don't want to use numbers. We'll just do it with variables. We're going to roll down D amount of distance. And so at the bottom we have Kekarot, and so on, right? So easy stuff. What we could do is find the final velocity using Kekarot. So how much energy do we have? All right, so energy is mgh. H is how far we fell, and we fell hypotenuse times sine of theta amount, d sine theta amount. This is my height, d sine theta, because these two angles are congruent. All right, is equal to Kekarot, so 1/2 mv squared plus 1/2 I omega squared. I for a disk is 1/2 mr squared, and then recall that we rewrite omega as v over r. V equals omega, so you get v squared over r squared, and the r's cancel, and then you simplify. You get v is equal to the square root, m's cancel. This is 1/2 plus 1/4, which is 3/4, and then invert it. So 4/3 g times d sine theta. There we go. And then from there is just a VOVAT. You're going from 0 velocity to final velocity, which we have here. Your acceleration is what you're looking for. Displacement is d. How far down you've moved. We're trying to find linear acceleration. And then plug and chug, use Leo, v squared is equal to VO squared plus 2AD. And solve for A. All right. Next up, when you ride a bicycle forward, in what direction is the angular velocity of the wheels? All right, just right-hand rule it. So if you're moving forward, it's going this way. Well, it's kind of hard to draw, isn't it? Well, here, let's do it sideways. So if I'm moving forward, here's my bicycle. So the wheels turn this way. And so the angular momentum or whatever, omega, etc., it's into the page. So if you're the one who's riding the bike, you'll see that it's to the left, to the left, to the left. A system of blocks. Ah, yes, this one was interesting because it looked different. Here's a block on a table, and then the block is attached to a string, and then the string is tied to another string with a box B, and then this string continues to go over an IDEO pulley, and then over on this side we have C, and our goal is to find what is the friction force on block A. This is A. We're trying to find friction. There's definitely friction, and it's static friction because the whole thing is in static equilibrium apparently. Well, not everyone got the same questions, duh. So obviously recall that static oh yeah, there's also an applied force. Well, that doesn't matter. Anyway, static friction is a dynamic force. It increases. The maximum amount is mu s Fn, but static friction is equal to the applied force. Applied force on the block. This is called force P, by the way, so let me use the proper variables. So apparently you're pushing down on the block with force P. Okay, the static force will grow as you pull harder. So let's call this tension, right? So as tension grows, static friction will grow up to the maximum. You don't necessarily need the maximum at all times. Now, over here, we have this tension here. Let's call this tension 2. Okay, holding up C, and because this is an ideal pulley, this tension is also tension 2. And so what is this block B doing? This block B is pulling it down. Okay, but what we could do simply draw an XY coordinate and see that the tension force that is pulling block A is actually the X component of this force, tension 2. F2x is equal to Ft, which is equal to the static friction force. So it was just, you know, Ft cosine theta. That's all it was. I believe they gave you the other angle. They gave you the angle from the vertical, but you can use 90 minus that angle, whatever. We'll call this phi. 90 minus phi equals theta. But anyway, so Ft2 cosine theta is equal to FFS. Ft2 is, of course, because of its static equilibrium, it's just m of c times gravity, mcg cosine theta equals FFS. If the magnitude of the cross, this one, we almost got it, almost, except for a couple that slipped on some banana peels. It says if the magnitude of the cross product, A cross B, is equal to 1/2 of the dot product, A dot B, find the angle. This is a freebie, right? Cross product is AB sine theta. Dot product is AB cosine theta. AB's cancel. Sine over cosine is tangent. Tangent theta equals 1/2. Arctangent of 1/2. All right. Next up, if the figure in the figure, yes, the spring question. I like this question. This was really cool. So we have a nice frictionless table. So frictionless table. We have a block, and the block is attached to 2 springs, like so. Okay, and at this point, it is stretched out some amount, L, but it says that it has been stretched out. Whoops. 0.30. So 0.30 meters. Okay. Now the natural length is actually 0.25, meaning both springs are overstretched by 0.05 meters, 5 centimeters basically. So both strings are already under stress. They're overstretched by 5 centimeters. Okay. Then it says you apply a force to pull on this block so that it moves a little bit. How much? It's going to move to the right 0.02 meters. Okay. And when you do that, you've actually stretched the first one by remember, it was already stretched by 5 centimeters or 0.05. Now you're going to the right by 0.02. You're going 0.07 for the one on the left, this green spring. But on the right one is only stretched by 0.03. Remember, originally both of them were 0.05, but because you're going closer to the blue spring, this is the blue spring is only stretched out by 0.03. And so to find the net force that you need to pull on this, the applied force that you need to pull on the block to move it 0.02 meters, you can just do, Hooke's law for both of them. But they point in different directions. So Hooke's law is kx. So those are the two forces. So 0.07 times k, which is 700, minus 0.03 times 700 newtons per meter is the k constant. Now why did I do minus? Well, that's because the two springs are pulling in opposite directions. And that should be it. So the amount of force that you need to pull it to the right is equal to basically the difference in the two spring forces at that location. All right, and then finally this spinning one. So here we have a pull, but we have two strings attached to our ball now, not just one. Two strings attached to our ball, and this ball rotates around kind of like a flag. The angles are given, so if I were to draw some horizontal lines like this, this angle here is 60, and this angle here is 60, therefore this angle here is 30. I'll use 2, there we go. And it says find the, what does it say? Find the tension. So, it says mass is 3.3 kgs. Okay, and this thing is spinning at a constant speed. It is spinning at such a speed that the tension is the same in both wires. So both wires have the same tension. We'll just call it Ft. Ft. So the tensions are the same. What is the tension? So find Ft. We can do some sigma equations and solve. Now, if you did x-axis, the net force is actually Mach, which is mv squared over r, but we don't know what the velocity is, so we can't use the x. So we can just go straight into sigma y and solve for it. In the y-axis, we have the y component of one tension, both tensions, sorry. So let's see, y component of this one is Ft cosine 60. That's the y component. The y component of the other one, I'll use orange. The y component of the other one is Ft cosine 30. And that should equal, well, minus the downward force, which is mg, and it should equal 0. And then you can solve for Ft because you know what m is. Just factor it out. Cosine 60 plus cosine 30. All right, on to the FRQ. FRQ is a E&M, parallel plate capacitor. Oh, it was so easy. So easy. So we put a little ball on a string inside the parallel plate capacitor. It has a mass of M, and it's being pulled to the left apparently. Variable power supply, DC, voltage, separation distance D. I mean, it's a uniform electric field, so easy stuff. Voltage is V. All right, describe the forces acting on the mass. So because it's being pulled, now was the mass charged up? Oh, it has unknown charge. It has unknown charge. Okay. It is charged up, but it has unknown charge, so that's why you can see how it's being attracted here. Let's see. So FBD shows us that the tension would pull us upwards to the right, mg would pull us straight down, and the electric force is pulling us to the left. So those are our forces. Derive an expression that would allow you to calculate the magnitude of the unknown charge. If you just carry on with sigma equations, you'll eventually stumble upon the answer. Derive an expression. All right, so let's see. Sigma equations. In the x-axis, we have ft cosine theta. Actually, theta is from the vertical. So they're giving you theta from the top, so I'll have to. I'm forced to use sine. So pay attention. So if the College Board gives you an angle, make sure you use their angle. So I have the x component is sine of theta, right? Because theta is up here now. Minus the electric field is equal to 0. Sorry, not field, but force is equal to 0. In the y-axis, we have tension times cosine of theta minus mg equals 0. So we can solve for the tension force. Tension is equal to mg over cosine. And then the electric force. The electric force equation. Well, there's two of them. There's the kqq over r squared for charged particles, but that's not the one we want. We want the other one, and that is E times Q, electric field times Q. Because it's a parallel plate capacitor, we can use the VED equation. VED tells us that V is equal to ED, and therefore E is equal to V over D. All right, and then just plug and chug, and then you can solve for what are we solving for? Driving expression for Q. Oh, okay. So Q times E is equal to mg over cosine theta times sine theta. Right? I've plugged in mg over cosine theta for tension and solve. And then E is actually V over D, which is equal to mg. Now sine over cosine is tangent, so tangent theta. And voila, we have it. Q is equal to mgd tangent theta over voltage. One way to determine a more accurate value for the magnitude of the charge on the conducting ball in the experiment is to perform multiple trials, obviously. What quantity would you vary in this experiment to obtain different values of angle theta? So okay, just look at the equation. What can I change? Well, in the experiment, I can change V or D. I can't change Q because that's the charge that I'm looking for. I can't change mass because that's the actual object. I definitely can't change gravity. So the only thing I can change is the separation distance or the voltage. Those things will affect the electric field. And when you change the electric field, you'll get different amounts of theta based on how much or how hard the ball is being pulled. What quantities would you plot on a graph to obtain a linear relationship that can be used to determine the magnitude of the charge? So basically, take your equation and linearize it. Linearize your equation. Here's our equation, this thing. We need to linearize it to solve for Q. To solve for Q. Okay. What I could do is take V to the other side. So I have V and then move everything over. So I have V times Q over mgd is equal to tangent of theta. So we've linearized it. So notice how it's in slope-intercept form. So y is equal to mx plus b. B is 0, so we're just going to ignore it. So whatever's in front, this is our slope. V is the x-axis, y is the y-axis is tangent. So I have to graph tangent of theta versus voltage. And when I do that, whatever the slope I get, the slope would be Q divided by mgd. And then from the slope I can isolate Q and solve for Q. All right. Describe one difficulty in precisely and accurately determining the angle theta with a protractor, and describe a method to overcome the difficulty. Precisely accurate. Okay, so protractors are great if your L and all that is really huge, right? The bigger your instrument is, the easier it is to measure angles, right? Now you have to somehow squeeze in a protractor inside the capacitors without disturbing, because you could if you touch it, that's going to change the charge, right? And not only that, if you get close to it, it is possible that the charges will jump into you. So you have to insulate yourself, and these are all like various difficulties of using a protractor to measure. If you take a picture of it, put it into Logger Pro, and then try to use a protractor, I suppose it's possible. One method to overcome would be to use trigonometry, of course. Or as I said, use Logger Pro and then use trigonometry. So take a picture of it. Once you take a picture of it, put the picture inside your Logger Pro, and then use trig to find, we're trying to find the top angle, find theta. So essentially you need to measure what L is. Since we already know what L is, we can actually figure this out. Again, honestly, I would do the Logger Pro approach. I think it's really cool, and I think the college professors who are grading your AP test would appreciate it. But make sure, don't just say, oh, let's use Logger Pro to find the angle. Actually, explain how you would use Logger Pro. So you would import the image, draw lines, use the ruler feature, make measurements, etc. Make sure you have something in the frame for scale, so you can get your pixel to meter ratio. What is that squid? What does that mean? If the voltage is high enough, the ball touches one of the plates. Describe what happens from the time it touches until you turn off the voltage. Well, it's going to oscillate back and forth. So why does it do that? As soon as you touch it, it's going to overload. So let's say this is negative and this was positively charged. We're just assuming right now. So all of the negative charges will jump on, neutralize it, and then make the ball negative, which will repel it. And once it repels, it's actually now attracted to the other plate, so it goes the other way, and then because it has too much energy, it'll go all the way until it touches that. Then it reverses its polarity, and so it goes back and forth, back and forth, back and forth until you turn it off. All right, so that was that. Let's take a look at the next quiz. Quiz stats. This one only had 3 MCs, so please take a look at your notes. We already did this before. We have a charge here. How much charge? 300 nanocoulombs. Okay. A hollow conducting sphere. The radius is given. I'm just going to call it R1 and R2. A hollow conducting thick sphere. Okay. The sphere carries an excess charge of negative. So the sphere already has negative. So let's call this Q. The sphere has negative 500 nanocoulombs. Okay. But if you put a positive charge here, of course you're going to get charges to come down and move out like this, so that charges line up. All the negative well, not all, but the negative charges line up here, and then the positive charges are on the outside, like so, right? And then, so what is my charge? Well, here it would be minus 300, And then what is over here? This would be Q. Chat, what is the, what does it say? Sub for a month, 13.7 kilo, mg over q, good job. If not tier 3 sub, then fake. Amazing. Mystery Wizard says negative 200. Very good, Mystery Wizard. Remember the difference between the outside, here I'll use blue, so all this plus, we're saying it's plus, but it's negative 200. Okay, it's plus in comparison to, or relative to, the inner. Okay. Oh, what happened? Plus, where's my, I put minus. Plus 200. Nope, that's not right. Minus 200. Yeah, minus 200. The total is still negative 500, as you can see here. We just shifted the charges a little bit. Why not all? Well, you can't have all, because they'll start repelling each other too, right? Remember, the charges want to go as far away from each other as possible. That's rule number one. But by having this inner charge, it's going to pull as much as it can. It's going to pull up to 300 or whatever it is. All right. The surface charge density of the inner sphere is closest to blah blah blah. Okay. Surface area, yeah, just surface charge density, sigma. Oh, whoops, not sigma. It is eta. Eta is equal to Q over area. Go where? All right, mechanics FRQ. Mechanics FRQ. Oh yeah, I mean, this is, area is 4 pi r squared. 4 pi r squared is the area. Oh, okay. Mechanics, so we have a force sensor, a cart, an elastic cord, a motion sensor. This seems familiar. So this is literally our lab. See how College Board just steals our stuff? So we have a force sensor, and then attached to a dynamics cart, and then over here we have our motion sensor. No, I can't steal it if I'm the one who's making the question before they even come up with it. Ooh. Maybe I'm just doing Inception. So the idea is that if you make the idea and then release it into the forums and people start talking about it, and then they think that they came up with the idea, then they're more likely to put it on the AP test. Consider watching Inception after you take your AP test. All right, anyway, we're short on time, so let's keep going. So we have the setup. What do we have? We have a velocity time graph. The velocity time graph looks like this. We also have a force time graph. Oh, look, fat equals delta P. Impulse graph. Yeah. Pew. Okay, this is 0.5. This is 0.75. This is -2 meters per second. This is velocity time. This is force time. -2 to +2. All right, so that's the stuff. Let's see. A, calculate the mass m of the cart. All right, how do we find the mass? Well, fat equals delta P. Delta P is the change in momentum. So use impulse momentum theorem. The integral, actually, they actually give you the area. They're telling you that the area is equal to 1 Newton seconds. So there's your impact. So you can use the area, and that's equal to mass times change in velocity. Yeah, this is the FRQ. For time period from 0.5 to 0.75, the force F, the elastic cord exerts on the cart is given as a function of time t, as F is oh wow, that's a mouthful. F is equal to A sine omega t. All right, where A is equal to 6.3 omega, okay, whatever, A and omega are given. Using the given equations, show that the area under the graph is, oh, now you gotta like integrate? Oh, come on. Really? Integral from 0.5 to 0.75. Yeah, it is technically easy, it's sine, come on. A sine omega t dt. Maybe calculate. The experiment is repeated using a different cord that exerts a larger average force on the cart. The cart starts and ends. Oh, what happened? Give me 1 second. My browser just closed. Man, I'm not having a good time. Okay, ready. Okay, so what was the question again? We're on part C. Blah, blah, blah. All right, the experiment is repeated. Okay, will the area for the graph of force as a function of time for the new cord be greater than, less than, or equal to? Blah, blah, blah. Of course, it's equal to. Why is it equal to? Well, you can say, since the cart starts and ends at the same velocity, the impulse on the cart will be the same as the area under the curve. Under the graph will be the same. Oh. All right. Yeah. Part D. What is part D? The elastic cord from the original experiment can be modeled as an ideal spring with force constant K. Yeah. Okay, so now we're doing simple spring stuff. Okay. Derive an expression for the maximum change in length, x max, for the cord. Express your answer in terms of m, k, v, VO, and physical constants as appropriate. All right, this is just conservation of energy. Make sure whenever you use conservation of energy in your explanation, start with the conservation statement. Mechanical energy initial is equal to mechanical energy final. So we have PES, so 1/2, so PES is equal to KE. So 1/2 kx squared, kx max squared is equal to, and make sure you use the proper, yeah, subscripts are important. So they're telling you, x would be a variable and x could be anything, but your PES energy, your maximum PES energy is what's equal to your kinetic energy, mVO squared. Otherwise, v would be a variable v also, and you're kind of neither on the sea nor the sand. For a correct, okay, then it's just, x max is equal to VO square root m over k. Easy stuff. Points off when you put O, not 0. Yeah, VO. I keep saying VO, but it's V0. It's technically called not. That was it. Oh wow, we're done. Cool. All right, so we went through all that. I mean, things are doable, but I feel like it's really easy to make mistakes. I read the email that College Board sent out, and in the guide, it said, "Don't be scared if the questions are too hard." Holy moly! You know what that means? The questions are going to be way too hard. What they said is, try your best, okay, and then they also said, because it's so hard, you don't need that many points to pass the test. Oh my god. Yeah. Good luck. Good luck. All right. So anyway, truthfully though, if you followed our model, if you followed our method, right, from not just this year, from day one when you came in as juniors, if you followed the method throughout, you're going to do fine. You're going to do fine. This is going to be easy. We're going to get all fives, 100% 5 rate. But if you did not do everything, and I mean everything, I even told you to organize your notes in a 3-ring binder. I didn't grade it this year, but it's a suggestion that keeps you organized. If you were disciplined, then this is going to be this is going to be a lot easier than your final. That's for sure. Let's talk about that final. The real test. 5/22. I found out that you guys are actually turning in your stuff after what is it? Labor Day. So there's no time at the end. So we have to move things. Yeah, we have to move things ahead of time. 5/22. You're gonna have a 6-hour window from 10 a.m. to 4 p.m. So you get a 6-hour window, but the test itself is only 45 minutes. Oh Lord is right. And it's going to be a combination. There will be a couple of MCs, just a couple, and of course FRQ questions. Yeah, basically. So yeah, I mean, it's unfortunate, but it is what it is. Now, what this means is that you're basically done with physics after the 22nd. I'll be available for Q&A. We'll talk about some random things, some fringe topics, not related, obviously. So no new assignments after this, obviously. The only thing that you have is the College Board FRQ and this final. Yeah. All right, so that's that. Over this weekend, things that you should do. Remember your college. Oh, by the way, I don't know if you read the assignment. So, Sword Hero, make sure you look at the assignment. There's a link on Canvas that says College Board FRQ, CB FRQ. On the video last time, I said to do 2019, but it appears that 2019 is not released to the public. It's only released to teachers and stuff. So that's why I'm going to have you do 2016. So you go from 16 to 18 instead of 17 to 19. Right? A good student would continue to do them, so keep going. No one's stopping you from doing 2015, 2014, 2013. And certainly when you prep for your final, you definitely want to do all the topics. Yeah. So over the weekend, of course, today finish up your actual assignment. From there it's just extra. So do more practice. Take a look at your 3-ring binder that you have. Take a look at your notes. Focus on experimentation. Focus on activities. Focus on designing things. Excuse me. So if you see a question that's purely calculation based, skip it. Don't do it. Focus on the justification type questions. In a paragraph length response, write this, those types of questions. So more justifying. All right, well, so Monday, obviously there's no stream. You are not allowed to talk about, so please do not talk about the test. They're going to release the stuff really soon, right? By the 26th, apparently. So So after they release questions, then you're free to talk about it. But do not talk about anything. Do not make memes. It's okay to laugh about memes, but do not make memes. Um, so don't do anything. Um, you know, play it safe. Just wait. We can talk about it the week after or whatever, during the Memorial Day week or the last day of school week. So yeah. All right. Well, I hope you enjoyed physics, and I wish you all the best. Good luck. Thanks for tuning in. I'll see you next time.